Cool. We're going to do the first half of 6.5 today, and it's about compound interest. Here's Steve. Steve's got $100, and he's going to put it into an account that earns some interest. Let's talk about what happens if you don't earn any interest first, right? Imagine Steve or whoever is just given a $100 bill, and they stick it under their mattress like they used to do back in the day before people started trusting banks, right? Because banks used to get robbed a long, long time ago, right? You know, so it's like they just put their money under the mattress. If you got $100 today, you put it under your mattress, how much is there in 1 year? $100. 2 years from now, if you never take it, isn't it still $100? If you never ever touch it, that $100 stays $100, right? But what happens is if you put it into like a bank or any kind of investment, you can earn interest. So check it out. Steve's got $100. He put it in there on January 1st of 2025, and he's going to get yearly interest, right, of 5%. So let's grab a calculator. Are you cool with this? After 0 years, like on January 1st, 2025, he's got $100 and he's made no interest. Let's grab a calculator and let's figure out what 5%, isn't that 0.05, times 100 is going to be. How much money in interest will he make once he leaves it there for 1 year? $5, right? So cool for him. He's now gained some money. But here's the awesome part. Like if this was under his mattress or in his account, he don't have $100 there no more. Isn't it $105, right? So now, if that money still sits there, like he doesn't withdraw any and he doesn't add any more money, isn't he going to earn interest not on the $100 again, but on the $105, right? So did you also see that I got a total of 105? Because yes, he made $5 interest, but didn't he already have $100 in the account, right? So he added those together. We're going to learn a little shortcut for that. Would you believe that he gets, so like here's his $100 plus the $5. Would you believe this money was his to start with, right? You know, that is 100% of his money, right? Isn't that 100% his, right? And then this, isn't this plus 5% interest in that case? If you added these two percents together, isn't that 105%, right? So the fast way to do that, to figure out the total price, is to take 105% and change it into a decimal. Well, remember, we moved the decimal 2 places to the left. Isn't that the number 1.05, right? So in our calculator, if we just take the money that you have, $105, would you believe he's got $105, and take it times 1.05, that will totally show us like how much he'll have that next year. And you would think, it's like, well, hey man, if he earned $5 interest the first year, shouldn't the next year he just get $110? Shouldn't he just have $5 interest again? I don't think so, bro. Did he have more or less than $110? More, because we didn't get interest on the $100, didn't we have the $105 in that case? So we actually made a little bit more, right? You know, and then would you believe the next year he's got $110.25 sitting in his account, right? So let's figure out how much he would be after 3 years. $110.25 times 1.05, because now he's earning interest on all of that, right? You know, did we get $115 and probably 76 cents? Are you with me on that? We'll round to like 2 decimal places. So boom. Look at how the interest is changing each time. After the first year, he got $5 interest. After the second year, he actually got $5.25 interest. After the third year, he got $5.51. Do you see how he keeps earning interest on top of interest on top of interest on top of interest? That's called compound interest. So I put it in a spreadsheet, right, to do all these quick calculations for me, and did the same old thing to see what happens if you left it in there for a long, 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 long time. After 37 years of just putting like it turned into $608.14. And every year, look at how his interest like just went up a little bit. He was making like $29 basically in interest. But what did the trick? Time. time is the thing that's going to make compound interest work for us. Cool? So we got ourselves a cool little snazzy practice sheet right here. Steve, in our example, was only getting interest one time a year, which is very rare. I know we're not the most financially savvy people right now because we are just freshmen, you know. We may have a job. We probably don't have a job, you know, but it's like when it comes to like saving money, we're not the best at that yet because when we get money, we like to spend it, which is awesome, right? You know, but to sit there and save money, it is very rare that people get interest one time a year. So here's some cool math words, right? They say if you got annual interest, you would get that one time a year. Semi-annual means you're going to get interest actually 2 times a year. So it's like, hey, you know, like if you put the money in the bank in January, then by July you earn interest, and then in December you earn interest probably the next January again, you know, so that happens. Quarterly, quarter means what number? 4. Monthly, if you got interest every month, this is the most common thing where you get interest every month. You get that 12 times a year. Daily actually does happen more often than you think. And then we'll talk about continuously in a little bit. But look at this mega formula right here. You've got to get that memorized. That's one reason why I'm breaking this into 2 lessons is so we can get this formula down, right? So what's all these variables all about? The A is your future amount. P is the cool one. In the finance world, your starting value is called your principal, right? And it's not like the principal of a school. It's just the financial principal. It's just like, hey, man, this is how much we're starting with. And then R is pretty common. It's your interest rate, but we got to make it a decimal. And then N is the cool one. N is the one that we might struggle with, like the number of compounding periods, and T is time in years. We'll dive way deeper into those as we go, but here's what I think we should do. We should read this problem and like substitute things into this formula. Suppose you deposit $3,000 into an account paying 6% interest. Here's the magic, maybe underline it, compounded monthly. Compounded monthly. How much will you have in the account after 20 years? Now, timeout. I know we are brand new at this. I also like to let you think because we are smart. Here's interest rates that are awesome for us because we know probably very little about good interest rates, bad interest rates, or poor interest rates. Anything 5% or bigger is a big fat thumbs up, right? So are we cool that 6% is like a thumbs up, right? You will probably never get anything over like 10% unless you're dealing with something crazy like stocks and things like that. But this is just like a banking situation. So bigger than 5%, awesome. Time is the real factor. How's our time right here? Is 20 years a pretty decent amount of time to let money sit in the bank? What do you think, yes or no? Yes. You know, 20 years is pretty good. So we should make some money here. We got a good interest rate and a good chunk of time. Let's put this stuff into the formula. So we're going to do A equals, do you know our principal? What is our starting amount? 3,000. Then what's really important is you put a parenthesis. Then it's going to be, according to this formula right here, 1 plus. Then we got this weird little fraction. R is our interest rate. We just can't put a percent into a formula. We have to change it to a decimal. What is 6% changed to a decimal? 0.06. You move that decimal 2 places to the left. Are we okay with that? 0.06. But then it's divided by n. And n is the number of times you earn interest. And it depends on what word they tell you. Sometimes they tell you daily. Sometimes they tell you quarterly. Sometimes they tell us monthly. In this problem, didn't they tell us monthly, right? So what number needs to go there? 12. Are we cool with that? And then close the parenthesis up. And then up here, let me erase a little bit, get this out of the way. We need n again. It's just that 12 times t, where t is our time in years. How many years is this bad boy going for? 20. We're going to do a quick recap because this is just our first one. A is going to be our final amount. That's going to equal our starting value, which is called our principal, times the formula says 1 plus our rate, 0.06, divided by n, number of times we get interest, is 12. All of that should be raised to the 12 times 20th power. Here's what I think would save us a lot of typing mistakes. we'll write that down. Let's figure this number out next. If you just use your calculator or your brain, whatever, what's 12 times 20? So I like to write that down, then strike this guy out and put a 240 right there. Are you with me on that? So before I go further, I'll push this in. I want to make sure that, I know we're still very new to this, you will not get 6% interest 12 different times a year. That would be awesome. What you're really getting is this. They take that 6% and they divide it up 12 ways. You actually get a 0.5% interest 12 different times a year, and that adds up to like 6% total, right? So you really don't get 6% every month. You get a 0.5% every month, and it just keeps getting interest on top of interest. So how do we punch this in? It's pretty slick, bro. We can just go from left to right. If we just use the parentheses properly, we're going to do 3,000, then parenthesis, 1 plus 0.06 divided by 12, close that parenthesis up, and then here's why we figured out that raised to the 240th power, so we don't have to put any more parentheses up there. If we just let that the 12 times the 20 was 240th. Then we're still new at this. Let's use common sense. We all make typos. It happens to me also. More or less than 3,000 bucks. What should we get back on this? We better get more. If we don't get more, we probably punched something in wrong, right? So just check that you punched it in. That's why I also figured out, should we make a lot of money or not? Yep, 6% interest is good. 20 years is a decent amount of time. We should make some money on this. So they had 3,000 bucks. Did you get this guy back? Yes, no, maybe? Punch it in one more time if you did not. Hey, money, how many decimal places, bro? 2. So 61 cents or 62 cents? What do you think? What we got to do is look to this number that's to the right of it. We want to look to the third decimal place. If he's 5 or larger, we'll round that up to 62 cents. If not, we're going to leave them the same. So $9,930.61. Dollar sign should come first, not last. Then they ask how much interest did they earn. I'm sorry that I spaced this out so weird. I should have given you way more space up here than down there. So if we want to start doing some work down here, that's fine. But how much interest did we earn? Here's the easy way. How much was our money to start with? 3,000. Now we got 9,900. So what do you do with these guys? You just subtract away your principal, right? Subtract away your principal, and don't you get 6,930 bucks? That's a pretty big gig right there, man. You know, what did you do to earn basically $7,000 here? And nothing. You let it sit in the bank, right? You just let it sit there. The patience is it took you 20 years to earn that money, right? It took you 20 years. So that's the hardest part about investing, is waiting for it, waiting for it. So, all right, let's try again. Suppose we deposit 2,500 bucks. There's our principal, into an account paying weirdo interest. Hey, is it bigger than 5? So that's going to be pretty good for us, right? Compounded how often? Quarterly. That means we're going to put a 4 in the formula instead of a 12 this time. 4 times a year. How much will you have in the account after 10 years? Just being honest with you, I know 10 years is a long time to you who are about 14, 15 years old. In the investment world, 10 years is, you know what I mean? It's not much. You know what I mean? It's, it's going to be okay. So we got a pretty okay rate at a pretty okay amount of time, right? We shouldn't make near as much money as we did last time. So I'm going to kind of go down here so we have a little more room. I'm going to start with my principal of 2,500 dollar bills. That's going to be times 1 plus our rate as a decimal. Man, that confuses people because they're like, isn't 5.8 a decimal already, Mr. Fonestville? And I go, sure. Does it have a percent sign next to it, though? Yes or no? Can't put the percent in there. Got to move that decimal 2 places to the left. So how about 0.058? Are you with me on that? Changing it from a percent to a decimal, divided by the number of times we get interest, which would be what this time? 4. Then we're going to raise it to the 4 times time, like n times t. It's still how many times you get interest? 4 times a year, times 10 years, And then I like to strike that guy out and put me a 40 right there. So let's punch this guy in. Talk you through some mistakes that people with a smaller calculator than me had a second ago. They could not get this to work out right because right here where they wanted to type this, they used the fraction bar instead of the divide button. You must use the divide button right there, and then it'll work out really, really, really good for you. So there's no fractions that go into this. It's a division. It's just on my calculator, my divide sign looks like a fraction bar. So it should be more than $2,500, right? But it shouldn't be that outstanding. We should also realize we shouldn't be getting $1 million back, right? You just put $2,500 in there. Ain't no way we're going to get $1 million back after just 10 years, right? So that's where maybe this decimal wasn't changed right. You used the number 5.8 instead of .058. So did you get that number, 4,400 something or other? Yes, no, maybe? Cool. 446.5, my bad, 4446.5, what, 54 cents or 53 cents? 54 cents. Let's try another one. Let's read it. Suppose we deposit 10 grand. Here's something I want you to get away from. It don't matter how much you start with, right? About how much money you make. It's about the interest that we get and the time, right? The starting money is the starting money. You can start with $1 million, and if you just leave it in the bank for a little bit, you're not going to make much money. But if you leave it in the bank for a long time, you're going to make a lot of money. Does that kind of make sense? So the starting value doesn't have much to do with it. How's our interest? Is it bigger than 5%? So we'll be all right. Compounded how often? Yes. Check out the chart. You know, how often is that? 2 different times a year. How much will we have after 4 years? Talk to me. Is 4 years a long time? We ain't going to make much money at all, right? It shouldn't be too much bigger than $10,000. It will be bigger, right, but not too much bigger. So let's start it out. I do need you to write it down, and then we do all the rest in our calculator. So you got to show me what you're punching in. So 10,000 times 1 plus, we got to change that 5.3% to a decimal, so 0.053 over n. N is the number of times that you earn interest. That's the semi-annually. So what number we want to put down there? 2. Thanks. 2 times 4 up here. That n times t. Just 8 total times. So let's punch this guy in. 10,000. Make sure you get the right amount of zeros on it also, because that sometimes causes an issue. Parenthesis, 1 plus 0.053 divided by 2. Remember, not hitting a fraction bar. Raised to the 8th power. Right. And we should have more than 10,000 bucks, but not much more, right? We got 12,000 something or other. 40 cents or 41 cents? 40, right? So we'll get that guy jotted down. $12,327.40. I forgot to figure out on the last problem how much interest we earned because I got distracted. So how much interest did we earn? Remember, $10,000 of this was ours, right? You know, so didn't we earn this new number minus 10,000, which is a pretty simple math problem right there, $2,000. 327 and 40 cents. Cool. Ooh. Look at how Mr. Ronenfield typed the next one. Read it. Talk to your neighbor. What's different about it? Is the principal the same? 10,000 bucks, 10,000 bucks. Is our interest rate the same? Yep. Is the time the same? What is different? Daily. Before we do any math. Here we earned interest, let's just say January 1st and July 1st. Twice a year. Cool? Here we earn interest today, tomorrow, the next day, every single day, right? How many times a year will we earn interest in a daily scenario? 365. We'll always use that, even if it is a leap year. Don't worry about it, right? So we'll always use 365. What do you think? Should we make more money? Yes or no? Than last time. Only thing that's different is the number of compounds. Before we do the math, guess how much more money we will make. Cool. Let's find out. Let's see what it is. So we're going to do 10,000 times 1 plus 0.053 divided by 365, and then 365 times 4 years, right? So I'm going to figure that number out first, that 365 times 4. We're going to get interest 1,460 different times in this period. 1,460 different times we are going to get interest. We should make some more money. 10,000 times 1 plus 0.053 divided by 365, close that up, raised to the 1,460th power. And I am always amazed when I hit equals on something like this. Because was it more? But was it very much more at all? Not much, bro. $12,361.29. And the interest that we made was $2,361.29. So we didn't make much at all, minus 10,000. How much difference did we make? Minus 2327.40. We made an extra 33 bucks by getting interest every day. Wouldn't you think you should make way more money than that because you get interest every day? But here's the thing. This is how much interest you get every day. You get your 5.3% interest divided by 365. See that big fat E in there, which is scientific notation? This has 3 decimals to it. We don't even get like a 10% of interest every day. So yes, we do make more, but it's really not much more in the long run. It would have to be there for hundreds and hundreds and hundreds of years for it to really make that big of a difference. Bad thing? We don't live that long. You know what I mean? It's like, that kind of stuff. So that leads us into the last topic of today. What if you got interest continuously? Before I totally explain this, I like to use this example. Financially, continuous interest doesn't happen that often. I'll show you an example in a second where it does. But let's say I went outside, and it was much warmer. I don't want to go outside in this cold. But I ate a banana outside, and I just dropped the banana peel on the ground. What happens to that banana peel as time passes? Does it decay? Yes or no? And you know what? Does it decay monthly or quarterly? Or does it decay now and now and now and now and now and does it decay continuously? Continuous growth and continuous decay is more of a science thing than a financial thing, if that makes sense. We're going to do some silly financial just to get used to this formula. But before we also break it down, you ever seen this number before in math? Pi. Was that weird the first time you saw it? You know, like 3.14159. It's like, okay, what's this pi? You know, I don't know, but they're making us memorize it. It's like about 3.14 something or other. It's a weird decimal. It's the ratio of the like radius of a circle compared to its circumference, kind of blah blah blah. Whatever. It's pi. That's an irrational number. Welcome to this number. The number is called E. And that freaks people out because isn't E a letter? It sure is a letter. But E is what we're going to call the natural number. You'll learn more about it in Algebra 2, but it is the rate that things grow or decay at a continuous rate scientifically. To find it on your calculator, if you have one of my calculators, it's located right here. If you see the number 4, it is to the left of it as a second function. It says e to the x right here. It will never even let you find it on your blue calculator somewhere. It will never even let you just type in the number E. You always have to raise it to a power. So if you want to know what E is, you're going to type it to the first power. But it's the number like 2.718 something or other. Just like pi was 3.14159, blah, 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 blah. Welcome to your second word that is very, very new. It is E, right? When do we use E? In continuous situations. And we have ourselves a different formula than before. Like, we're not going to use this. This is called the compound interest formula. This formula for continuous, we just quite simply call it PERT. Because doesn't it, like with all these variables involved with it, spell out the word PERT, right? Just got to know where the letters are. P, R, and T are the same old story. P is your principal, your starting amount. R is your rate. T is time, but you notice that T and R are both up in the exponent, and E is down as the base. So Yolanda deposits $1,000 into an account that gets continuous interest at a rate of 5%. How much will she have in 10 years? PERT is how we do it. Why do we use PERT? The word continuous, right? The word continuous. Principal, could you tell me what that is? 1,000. Then you'll write the letter E, and then here's the other just wacky part. It's just 0.05, right? Sometimes we like had that 1 plus. That has nothing to do with it anymore. It's 0.05 times time in years, which in this case is 10. We've got a very nice rate of 5%. We've got a meh amount of time. We should make a little bit of money in this scenario. How do we type it in? You can figure this out ahead of time if you want to, but when you do PERT, it's not that bad to not type it in. Was it $1,000? Is that what we started with? Yeah, $1,000. So type 1,000. Then you've got to find your E button. Like I said, mine is to the left of the number 4. Find yours on your calculator. I can help you in a little bit. So E to the, you see it should automatically start you in an exponent. Maybe you have a little caret on your calculator already. Does it have a parenthesis for you? That's the question. If there is a parenthesis, you're going to be groovy to just type the 0.05 times, what, how many years was it, 10? But my advice is, if it doesn't have a parenthesis, to put those in parentheses. Mine, I didn't actually need to put it in parentheses because I was up in a superscript, you know. But the moral of the story is you'll find out real quick when I hit equals if you typed it in right, if you get the same number as me. Did you get the number back? So it's just learning how to type it in your calculator. If you wanted to figure out the 0.05 times 10 ahead of time, awesome. That will just save you that little headache of like, I can't get it. But mine, I don't have to do that because it puts it up in the superscript. I can just type 0.05 times 10 and it'll figure that out for me. So 1648 and how many cents? 72 or 73? So 1648 and 72 cents, right? They don't ask us how much interest to make this time, but just in case they didn't we make $648.72 interest? Right? So let's try it one more, but before you punch it in, I want to talk about it. Rita has got this much money, 3, 4, 5, 6. Tell me, what is making us use PERT? What word made us use PERT? Continuous, right? If they say monthly, if they say quarterly, if they say annually, if they say daily, that's the other four, right? This is a PERT scenario. Hey, how's our interest? Really good. How's our time? Amazing. Time is amazing. 40 years is a long time, right? 40 years is an awesome amount of time. Cool? I could be dead in 40 years. Do you know what I'm saying? It's like, it is an amazing amount of time. So let's do it. Principal, 3, 4, 5, 6, times E to the 0.06 times 40. We should make some serious money, bro. Serious money. Because of the time being long and the interest being pretty okay. 3, 4, 5, 6 times E to the 0.06 times 40, baby. We started with $3,000 and some odd dollars, and we just let it sit there, and now we've got $38,000.96, or shoot, $38,096 and how many cents? 9 cents or 10 cents? 10 cents. Holy macaroni. Is that an awesome thing right there? Cool. We made like $35,000 plus, all by letting it sit there. That is cool. Let me know if you have any questions. Have a good one.